Because we're launching a rocket. That's what we do here, right?
We're gonna light this candle.
This is bottle rocket science.
Bottle rocket science, exactly. So welcome to our SEVDNUG for February. Yeah, February. I think about that. It's a long day.
Last day of February.
Last day of February. That's why I had to think so hard about it. So we've got some events coming up. We've got Arizona Gift Camp. It is a nonprofit hackathon. It's us as developers and creatives giving back to nonprofits. A little different than the typical hackathon, where it's all about prizes and competition. We are not about prizes or competition. It's our opportunity to truly give back to nonprofits. That's going to happen in downtown Phoenix at the Quicken Loans office on March 8th, 9th, and 10th. So we typically start about 5 p.m. on that Friday, meet all the nonprofits, figure out what they actually need, form some teams based off whatever your interests are, and then start hacking away on it. And we'll go all the way through Sunday afternoon, do a presentation at the end. We provide all the food, all the caffeine. It's up to you if you actually want to sleep or not. You can hang out there for the full time. You can go home at night. Totally up to you. But we will be hacking away for those 3 days. Do we have any other events that people want to announce that are coming up? Anybody hiring? And thank you for sponsoring. And it's Phoenix staff.
It's Phoenix staff, yes.
Yes.
There is a company called Phoenix Staffing, which does staffing for property management and real estate people. So if you're looking for Phoenix staff and get Phoenix staffing, just hang up. Try it in. So my name is Tejal. That's my partner Matt. We sponsor the pizza, which I've been forcing you guys to eat. We are hiring for multiple developers, .NET and Java, as well as VAs, BI developers. We have a PM role, we have a software dev manager role, so all across the valley, from North Phoenix all the way to Chandler, and we also have some in Tempe. So if you are looking, or if you have a friend that's looking, and you refer them to us, and we can place them, we do pay out referral bonuses. Extra cash. Doesn't like extra cash.
Exactly.
Nobody likes extra cash.
No one likes extra cash.
Well, I'll take yours then. Thank you.
So if you refer and you don't want the cash, I'll give it to him.
Yeah. Yay.
There we go. Is anybody looking? It's always the golden question. I know it's one she can't ask if you won't ask, but I'll ask. If you are looking, hit them up before the leave. I'm assuming you're not staying for the full time, or are you? You're always welcome to stay.
No, we had family. But we do have, actually have an event that we are hosting at Phoenix for developers.
When?
In March? Yeah.
That would be great if you could go on the Meetup site and throw a comment into tonight, so where they can register for that and all those event
Yeah, absolutely.
details for people. I'm sure you have a registration somewhere for it.
Well, you just have to email my partner Bill. I can forward, put it on the Meetup page. It's March 21st at the Deuce, I believe it's pronounced, from 5 to 7 o'clock. Food and drink will be provided. So if you like food and alcohol, come on over.
Awesome. And I forgot about, thank you. I forgot about a couple events coming up. The Visual Studio 2019 launch event is coming up April 2nd. So Microsoft will be broadcasting like 6 hours of content for that piece. For the Phoenix area, we are actually doing our launch event for VS 2019 on April 16th at Galvanize. We have that on the Meetup site, I believe, already, where you can go register. It's a free event. We'll have at least a half day worth of content. We're kind of waiting on Microsoft to deliver the content to us, because they do event in a box for their launch events, but they haven't delivered their contents. Can't tell you exactly what will be there, but it'll be all about VS 2019. Last time we talked about all their cool new features in there. Brought out a bunch of speakers last time, so we plan to do that same thing. Can't beat the free event, and you can find some other .NET developers. We put out about 60 .NET developers. Obviously a lot more than what's in this room, so we know there's more in the valley than just us. And with that, I'm going to turn it over to you guys. I'm going to let you do your wonderful introduction. You are fantastic.
Coming to the 2019 preview?
Repeat that question?
They're Microsoft employees.
They are not Microsoft employees. He's coming to our local event.
Are they out of town? MVPs or?
Yeah. So right Right now, it's the three confirmed are myself, Rob, and Barry. We're talking to a whole bunch of other speakers. Because they haven't delivered the content, it's really hard to go find speakers right now. It'd be like me coming to you and going, hey, do you want to speak at the launch event? I can't tell you what I'm going to have you speak about, but are you interested? It's like, so we're doing that.
You can download the RC.
Yes, but they deliver presentations to us. So you'll see a ton of stuff at their launch event. They'll have a ton of stuff for us to deliver locally as well. And so we're hoping to bring out like Dan Wallin and maybe some of the other big .NET developers that are in the Phoenix area. But we do not have the confirmed list. We are still in the planning stages. We just know our date and location right now, which is our first thing that we needed. So that'll be April 16th for our local one at Galvanize.
Are you guys we're gonna just leave this pizza here.
We'll make sure it gets taken care of.
Okay.
It'll be dealt with.
Kids all across the world.
Yeah, you notice the guy in the corner that's starving because he's playing in the Bitcoin world.
Wow. Don't let the pizza go to waste. All right.
It won't.
They won't. Thank you for sponsoring again.
Yes, thank you.
Thank you. Cards here, obviously, if you guys are good where you're at, that's all we ask for. That's all we're looking for from anybody. But if you know anybody, certainly referral fees. It's a good market right now, so it's a good day for you guys.
Thank you. And with that, Guy, take it away and teach us all about Bigfoot sightings.
Bigfoot sightings. Okay. I was going to, you probably didn't see me, but I raised my hand that we're hiring too.
Oh, you're hiring.
Yeah. So in addition to me being a developer evangelist, apparently I recruit as well. So DataRobot has a ridiculous 260 some openings on our careers page. Now those aren't all developer jobs. I mean, some of those are, hey, we need an admin for, the Seattle office or whatever. But many of them are, and so we're looking for front-end JavaScript developers and back-end Python developers for our product. So if that's you, you should go to datarobot.com/careers and see what's available, and you can apply online if you like. Or you can email me, and I can send your resume in, and then I'll get a bonus, and that'd be fantastic. So, because like I said earlier, I like extra money. So. Anyhow, so welcome. This talk is called Beyond the Model, Operationalizing 4,586 Bigfoot Sightings. And that's for those of you who can't read. For the rest of you, it says it right there. So, and you can tell that it's, I work for DataRobot because it's on the slide there. Turns out it's actually on a lot of the slides. So, my name is Guy Royse. I'm a developer evangelist at DataRobot, which in the long and short of it means I'm working right now. So a significant part of my job is to go out to events, talk to developers and say, hey, DataRobot's a thing. And so I'm here to say, hey, DataRobot's a thing, but I'm going to do it and be entertaining at the same time so you won't feel like it's a sales pitch. It's not really a sales pitch. I've been a developer for a long time. I post things on Twitter about being a developer for a long time and about things that happen, just things that I think are interesting. So if you're on Twitter and you want to follow me, you can follow Guy Royse. If you want to @ me during the talk to mock me mercilessly so that it shows up on my phone while I'm trying to concentrate on the talk, you can do that as well. In fact, I will have my phone screen on the display up here later, and so if you tweet me at just that moment, your message will show up saying, so-and-so mentioned you. So actually don't do that, never mind. So, if you can go out to github.com/GuyRoyse, the code that I'm showing here, you can get to a lot of it there, a lot of my sample projects and stuff that I've worked on. So check that stuff out. This is a very important piece of information. Can anyone guess what this means? Except you saw it last night. That'd be cheating. Shut up, you. Also, you may only answer if you're a woman or a man of slight build. And that's because I only have women's t-shirts and one men's small t-shirt. Any guesses? Your stunned silence is very reassuring. Data scientist, that's right. Would you like the medium or large women's t-shirt? Yeah. I've also got a men's small here too, so.
I'm a nerd on data scientist.
You're a nerd and data scientist? You pick whichever one you like here. Okay. A nerd and I ain't not a data scientist. Yeah. I am not a data scientist. So I do talks about machine learning as a developer. But I am not a data scientist. I'm not striving to be a data scientist. I'm a developer. I've been writing software for a long time. I like writing software. Data science to me is a tool that I can use to add behavior to the applications I build. And tonight I'm going to show you some applications that I built using, well, they use DataRobot ultimately, but focus more on the applications I built. But they're applications, right? That's the goal here, right? I do know a bit about data science simply because I've been learning about it for the past 2 years, giving talks on this topic and stuff. I'm certainly not an expert, but you don't have to be an expert to use a lot of these data science tools. So, you know, if you want to use scikit-learn, you don't need to know how an algorithm works in order to make use of the library that implements that algorithm in your code to build a model. So, and that's the kind of stuff that I tend to do. I do figure out how the algorithms work because they're interesting, and understanding them can be useful when it doesn't do what you expect it to do, but you can also get reasonably far black boxing things. So, not a data scientist. I am, however, an enormous fan of Bigfoot. And, you know, I mean, there's a lot of reasons for that. There's just something fundamentally fascinating about this idea of a large, hairy humanoid out in the woods. I just described myself camping. But, but there is something compelling about that idea, right? You know, is it Chewbacca, as we heard the non-canon Star Wars comic book tell us? No, it's not Chewbacca. I'm sorry, you're wrong. But there's just something really interesting about it, and it's interesting the cultural phenomena around Bigfoot as well, right? You've got this, all these people that see Bigfoot, but no one's been able to get a good picture of Bigfoot. He's always really blurry. Actually, there's a comedian who, I wish I could remember his name, has a joke about that. He says, the terrifying thought is maybe Bigfoot's actually blurry. That's really scary, right? So he's not, and I know this because I actually have a slight confession to make, and that's that Bigfoot is my father. This is the last picture I got of my dad before he left. Him and my mom weren't getting along. And I haven't seen him since, I was probably, about 12 years old. There was a period of time where, him and I were hanging out after my mom and him separated. But I haven't seen him since. I've been trying to find him. And so I thought, maybe I could use data science or something to find Bigfoot. And, but I went down the conventional routes first, right? So I decided to go to the journalists, see what the journalists are writing about Bigfoot. There's apparently a lot of cutting-edge journalism happening in the Bigfoot scene. This is from the Weekly World News. Dozens of witnesses have seen Bigfoot roaming in the wilds with a human child. That's me when I was about 10 years old, running through the woods with my dad, wearing my whitey tighties. You can tell the hair hasn't changed much. You can tell this is an authentic article too, because you've got actual scientists on the bottom left here who are wearing those wonderful 80s amber vision sunglasses that make you look like the Unabomber. Of course, it's got a true study here which says that smoking apparently makes you ugly. I don't know if that's true or not, but scientists said it was true, so it must be. But the problem is I went to these journalists, and all they could do is dig up stories from my past. This isn't really helping me find Dad. It's just saying, well, this is more of a pleasant childhood memory as we ran away from the Hendersons after stealing things out of their station wagon. And so I thought, well, maybe maybe I'm asking the wrong people. Maybe I need to go talk to the experts, the Bigfoot experts. And so I did. And so I went and found the Bigfoot finding people, and well, they don't find Bigfoot. The thing I love best about this picture is that there's, they've got 3 true believers and a skeptic. And you can tell who the skeptic is because she is Scully to their molders. And the look on her face, I just absolutely love it. She's like, am I really getting paid enough to do this? She's just, the guy on the right, he's just smiling and happy. Hey, I'm doing Bigfoot on TV. And she's like, hey, I'm ruining my career. But yeah, I went to them and said, hey, can you help me find Dad? And they couldn't. But the guy on the right actually is the president of an organization called the Bigfoot Field Researchers Organization. And he founded it in 1995. And you can tell that because they haven't updated their website since. And they are the self-proclaimed only scientific research organization exploring the Bigfoot/Sasquatch mystery. And yeah, they're a real organization, and they've got data about Bigfoot. They've got this comprehensive sightings database they mentioned over here on the left, right? And so I'm like, great, I could download the database and do some machine learning, and maybe I can figure out where Dad's at, or where he's likely to be, and then be there when he gets there. But how many of you have ever done documentation for work from like a Word template, and you got to fill out all these sections, and some of them are filled in and some of them aren't, and they're just kind of whatever the hell you felt like writing, and they're not really, it's a report. It's not data. That's what their comprehensive sightings database consists of. It's all these web pages. There is an ASPX file, so they're doing .NET, sort of. They're kicking it old school. At least it's not a .asp file. But it's got all these gaps, and it's like they've got a SQL database somewhere that's just got a bunch of just text columns filled up with whatever they wrote. And so it's not super useful, and you got to click through. They're just being put on the screen, so they weren't useful to me. And then, as it turns out, the internet has everything. This is Tim Renner, and he is obsessed, as he says, with weird data. And I love that he's wearing a tinfoil hat, because he's got data sets that he's screen scraped from this site. And so he wrote some Python code to go out and screen scrape the BFRO's website and build a data set of Bigfoot sightings. He's done the same thing from the Shadowlands Haunted Places Index to build a data set of haunted places in America. And he also screen scraped the National UFO Research Center, the New Fork, for all their UFO sightings. Incidentally, 120,000 UFO sightings. And let me tell you, the text of some of these things, delightful to read. My favorite was was entitled Megatron in the Bushes. Apparently they heard something that sounded like Megatron out in the woods. I don't know. And so he's gathered this data for us to play with. And so I cared about the Bigfoot data because I'm trying to find my father. And so that was what I focused on. I actually kind of interested in the UFO data as well, because I feel like maybe this is like, Uber for Sasquatch. I don't know. And so maybe there's a correlation between UFO sightings being up and Bigfoot sightings being up. So
is Tim scraping new data?
He hasn't recently. He just did it to build a project, right. Which I'll talk about actually.
The data's going stale. How are you going to find data?
I know, right? Well, he's got all the code to scrape. I could rerun it to scrape it myself. So, assuming they haven't changed their site. But he's also gathered up data on Dogman, which apparently is a thing. So,
Dogman?
Yeah, I never heard of Dogman, but apparently it's a thing. And so the data for Bigfoot's kind of interesting. Here's just a sampling of what's in there. These are the interesting fields. You've got this date of when the sighting occurred. And dates for machine learning can be really useful because there could be natural seasonality in the data. Like, you know, Bigfoot's seen more often on Wednesdays than on Fridays for some reason. And in other machine learning problems, this is useful if you're trying to predict, say, pizza sales. Pizza sales increase as you get later in the week, and then they taper off on Monday, right? If you're trying to predict, you know, how much a house sells for, houses sell better at different times of the month and different times of the year, that kind of stuff. So dates are useful for machine learning, but they're not really a field in and of themselves. They're a source of data that you can use. When you pull them apart, they get meaningful. And so we might be able to use that. There's a ID here. That's a unique identifier for each Bigfoot sighting. That is utterly useless for machine learning because they're all unique. There's no pattern to be seen in there. And so this is not something we can use. We've got the text of the Bigfoot sighting. This is the handwritten eyewitness account, or not handwritten, but the written eyewitness account of their Bigfoot sighting. And so this is just like the title of it here, but there's a full text. You know, a series of large human-like footprints are found on a farm near Wayne National Forest, which is in southeastern Ohio, which is not far from where I live. There's a class, which is also interesting. The report, the text, you can do natural language processing on this and maybe be able to use that as a feature in some sort of prediction you can make. The class, that could be interesting. You might be able to predict what kind of class the report is. There's different classes of Bigfoot sightings. This is a good example of a categorical field. Is it Class A, Class B, or Class C? What category is this Bigfoot sighting? Bigfoot sightings come in 3 categories. Class A is, I saw Bigfoot. Class B is, I found evidence of Bigfoot, like a footprint, or maybe I heard some noise. And Class C is, someone told me they saw Bigfoot, which is by far the most reliable of all the classes. There's also latitude and longitude, and that could be useful if you're trying to figure out where Bigfoot is. You might be able to predict where he's going to be next. But there's another column hidden in here that's sort of implied but isn't explicitly defined, and that's the quantity of Bigfoot sightings. On every date, we know that a Bigfoot sighting occurred. So the existence of a row is data in and of itself. And so we could use that quantity and say on, you know, January 15th, 1958, there was 1 Bigfoot sighting. And we could aggregate that together, and so if we had 2 sightings, you know, we'd have 2 records, we could add that up and get the quantity. And I actually did that because I thought it might be interesting to see what it showed, and I thought it might be, maybe I could predict the number of Bigfoot sightings based on historical numbers of Bigfoot sightings. And so I plotted them out. And this is a chart showing the height is how many Bigfoot sightings there were, and the width is the date. And it starts on January 1st of 1950 and ends on December 31st of 2016. And so each of these boxes in here, you can't see them very well on the projector, but there's a bigger box here, and then it's made of smaller boxes. And each of those smaller boxes represents a year. And so every single time you see like a little spike here, that's a year. And this is hands down my favorite chart because it shows you just the scope of Bigfoot sightings. The first thing you notice in this is what? What are these peaks? What happened here? This is this peak here happened in 1978. This peak here happened in 2006. So that's kind of interesting. I like to think that this is the result of the $6 Million Man being popular in the 70s. And once that episode came out with the 6 million with Bigfoot in it, played by Andre the Giant, that sort of led to an increase in Bigfoot sightings because people were thinking about Bigfoot. And over in here, this starts around 1995, 96. That correlates with when the X-Files came on the air. And so, and then this correlates with when it went off, about the time it went off the air. So clearly, we're increase in Bigfoot sightings corresponds with television.
That's weird, nothing around
That's because everyone was making fun of Harry and the Hendersons. It's all about TV and movies, right? Yeah. These peaks are interesting, but there's actually a more interesting, and I have a theory as to what they actually represent. But the fact that the data is lots of peaks and valleys as opposed to being smooth is interesting in its own right, because each of these peaks is in the middle of that box representing a year. Because I aggregated all my Bigfoot sightings monthly. And so each of the points on that graph is a month. And what it means is that there's more Bigfoot sightings in the summer than there are in the winter. And that's because Bigfoot hibernates. Right? No. Right. We actually don't know why that is. Well, I think it's fairly safe to assume that there's just less people in the woods in winter. And so we don't have any sightings. We don't have data. We don't know if Bigfoot's out and about because we're not measuring Bigfoot population here. We're measuring Bigfoot sightings. And so we have an absence of evidence. But that's not evidence of absence. It's also not evidence of presence. It's just no information. We don't know if Bigfoot's there or not in the winter. He could hibernate, he could not. This data doesn't support or refute that hypothesis. Well, it supports this hypothesis in the same way that my theory that there are ghosts and they're invisible and undetectable, but they're everywhere, and the proof is that you don't see any. Right? It's that kind of, we just don't have any data because no one's gathered it, so we just don't know. And so that's kind of interesting because that's telling us something about our data, right? Our data isn't just why are Bigfoot sightings going up and down, it's just people seeing Bigfoot. I actually honestly think that these two bumps, these spikes here, this one I think is just sort of, I remember the 70s. Honestly, I think this is acid. I think everyone just did a lot of blotter in the 60s and 70s, and then years later, it's like, that's Bigfoot, because it couldn't be a flashback. No way, it's definitely Bigfoot. And so, and honestly, the 70s just sort of had that feel to it. Everyone was into this kind of stuff, and so I think everyone was kind of wanting to see it. And so they'd see, a grizzly bear stand up on its hind legs and think, oh, that's Bigfoot, because it's far away. And that classic photo of Bigfoot walking through the 8mm film of him walking through the woods happened in the 60s, and leading into the 70s. That may have influenced that as well. I don't know. But the spike over here is way more easier to interpret. There are two significant events that happened in 1995. Can anyone think of what they might be? I'll give you a hint. Al Gore invented it. The internet happened, right? And so, and more specifically, the BFRO's website was founded in 1995. And so, it used to be when, your Uncle Cletus talked about seeing Bigfoot, you just tell him to shut up, we don't want to hear the story again, right? But once he got on the internet, he could actually tell someone about it. And so the internet facilitated that communication, the BFRO's website facilitated that communication, and so the number of Bigfoot sightings spiked. Because the sightings didn't go up, the reports of sightings went up. And so we're actually measuring the reports of Bigfoot sightings. And so there's some lessons about this data in here that we've gathered.
Class C is the least reliable?
Yeah.
So
technically, they'd all be Class Cs, wouldn't they?
the story.
Yeah.
Lead us on a road trip.
Yeah, lead us on a road trip, yeah. And technically, they're all Class C if you really think about it, because everyone told the BFR their story, and so the BFR was like, "Oh, someone told me they saw Bigfoot." So, interestingly, the data set has very few Class C Bigfoot sightings, and so the model that I built using these is very poor at doing that, as we'll see later. So, I did do some playing around and measured the impact of the X-files over this time period, and it showed that correlation is causation. and totally we should read into our data everything. But this data is interesting, but it's actually not very useful. As far as, I mean, it's interesting to look at, but it's not going to help me find my father. And so I thought, well, let's look at the GPS data. That's about place, right? You know, maybe I can find a Daddy Bigfoot that way. And it turns out that's exactly what Timothy Renner used the data he gathered for in the first place. And so this has already been done for me. I don't have to do this. And so Tim, he went out and took that latitude and longitude, and he plotted it on a map, and then applied a clustering algorithm to it to find the natural groupings. And so, you know, in what areas is Bigfoot more commonly seen, and what areas is he not? And he generated this chart on the left. You can see, unsurprisingly, there's a cluster in the Pacific Northwest, because that's where the legend of Bigfoot comes from. There's, you know, some here in California. This is Ohio over here, where I'm from. Prime Bigfoot country, which makes sense because that's where Dad and I used to run through the woods all the time. This is the Appalachian Mountains. There's a large number of sightings of Bigfoot in the Everglades in Florida. And so he found these natural patterns. I like that there's a fair number here in eastern Texas as well, which kind of makes sense. But he looked at this. He's trying to find, you know, what's the pattern here, right? What's going on here? And so he overlaid it over a vegetation map, and he realized that if you looked closely at the patterns, you could find Bigfoot in the woods, which is we kind of knew that already. So we've used a bunch of computing technology to tell us something we already know. It was a fun exercise. Bigfoot's in the woods. Good to know, guys. Thanks. And so I decided to do something different. I decided to use this class and the report and build a model that would allow me to type in a Bigfoot sighting, the account of a Bigfoot sighting, and then tell me what class it is based on the 4,586 Bigfoot sightings that we have. And so that's what I did. I decided to classify them. So you got class A, B, and C here. So class A, I saw Bigfoot out by the woodshed. He was 12 feet tall and covered in hair. I didn't like the cut of his jib. That's class A. I saw Bigfoot. My dog heard a weird sound in the woods. The next day, we found a large footprint by the creek. I said crick on purpose. That's class B. It's evidence of Bigfoot. And then class C, my grandfather used to tell me about the time he saw Bigfoot back in the 30s. He was walking along Moonville Road when he heard a large crash. Incidentally, actual picture of my grandfather. He doesn't look like Bigfoot. Obviously, he's my maternal grandfather. So the idea is that I can type this into some sort of thing and spit out class A, class B, or class C accordingly, right? And so I built an app to do that. I built 3 apps that do that, because I thought there's really 3 different scenarios you might need to be classifying Bigfoot sightings. There's out in the field. You know, you're out there, you're at the trailer park, you're talking with the person who saw Bigfoot out next to their camper down in the Everglades, and you need to figure out what kind of story this is. And so you can type their story into an iOS application, hit the big fat classify button, and it'll tell you. That's, you know, oh, good. Now I know that this person merely found evidence of Bigfoot because it's class B. They didn't actually see Bigfoot. But if you are working at the office, maybe you've gathered lots of notes, or maybe you're at the Bigfoot hotline, and you're at a computer. And so I built a web app using Vanilla.js to classify these Bigfoot sightings, and so you can type them into a web application instead. And so that's, you know, a little more friendly. You know, you're at your desk, you're working, you can get them in there that way. And it's also possible that you might need to do bulk Bigfoot classification. So maybe you have a text file full of Bigfoot sightings that you need to classify. And so I built a command line tool that you could do, and you can just pipe the standard input into the tool, and then it will spit out a CSV file with all the classifications of those Bigfoot sightings for back office applications. so you can automate shell scripts and stuff with it. And I built that with C#, in C# with .NET Core, because why not? And so I got 3 important applications here. They have different uses for the important work of classifying Bigfoot sightings. This is how I built them. This is sort of a high-level picture of how this works. Here's my 3 applications: my iOS application, my web app, and the command line tool. They all make use of a REST API written in Python using a library called Flask. Anyone heard of Flask? A couple of you. Flask is sort of like Express for Node, or like Sinatra in Ruby. It just lets you do a little line that says, hey, when someone hits this URL, run this code. And when someone hits this URL, run this code. And so I use that to build a REST-based API that'll allow you to get the version of the software and information about it, and to do a classification. And that code then talks to DataRobot using our API, and I built the model using DataRobot because it was really easy to do it that way. And so I can show you these applications in work, functioning, and then we can go into the details of whatever apps you guys want to see. It's up to you guys. We don't really have time to do all of the applications. We got about half an hour left, I think. And I don't want to necessarily go through 4 code bases and DataRobot, but you guys can pick and choose what you'd like to look at. So let's do a demo here. So I've got, let's start with the mobile app. So launch the Bigfoot Classinator. This is the part where I get the embarrassing text message from my wife. And so this is actually running on my phone right here. I'm just using QuickTime to put it on here. And so if I go in here and say, I saw Bigfoot in the woods today. I've done this demo a lot, and so my phone has learned that when I'm in this app, these are the words I can type, and so I can actually just auto-complete it quickly. I hit Classinate, and the first time is going to take a little while because the REST API is hosted on Heroku, and the instance needs to spin up. And so there we go. So I saw Bigfoot in the woods. That's a Class A Bigfoot sighting. It's a Class A Bigfoot sighting. Hooray, it works. Let's do, I found a large footprint by the, large footprint by the woodshed. Did I spell shed right? Probably. Hit Classinate. You see that came back a lot faster because everything the instance spun up. So Class B, that's evidence of Bigfoot, like a footprint or something. So it's taking just text for humans to read and turning that into classes, which is pretty cool. We can do the same thing with the web app, and this web app is hosted on Bigfoot Classinator, bigfoot-classinator.github.io. So you could actually go to it right now and hit it if you are so inclined. And it is responsive, so if you hit it on your phone, it'll work as well. And so I could do the same thing in here, but I think it would be a little more interesting to go out to the BFRO site and pull a live thing from their comprehensive sightings database. You can tell their website's changed a little bit here. Apparently there's Bigfoot in China, and he's 2.5 meters tall. Sorry, a fly just flew into my eye. That could have been my hair, I don't know. So let's go to the recently added reports here. Ooh, sound recordings, that sounds fun. Oh, I lied. It is a .asp file. gbd/newad.asp ? Show AB. So it is actually, it's not an ASP.NET application, it's an ASP application. Kicking it old school. So, oh, here's one in Mahoning County, Ohio. Coyote hunter's possible encounter with white-furred juvenile. I didn't know juvenile big feet were white-furred. I'm not white furry, so I don't know, but I guess I'm a half-breed. I don't know. And it happened in November of 2013. Let's take a look at this. Okay. I was going coyote hunting in North Lima on my in-laws' property. I was grabbing my gear out of my trunk, and through the tree line I could see about 5 turkeys in a field. This sounds like a real story. I know people like this. Okay. I've copied that. Let's go into the Classinator and Classinate that sighting, see what it says. It's a Class A sighting. So they saw Bigfoot, it worked. Cool. Let's look at let's just go to the next one. This is supposed to be a Class B sighting. I keep hitting Alt Tab, Command Tab, and that's not going to work. Let's do that one. It thinks that's a Class A as well, so it is machine learning. It's not always right, but people aren't either. So, but so obviously I'm doing the Bigfoot hotline work here, and then we've got a command line tool. Let's take a look at the command line tool. It's actually my favorite. Just because it's kind of ridiculous. I've got this file called sightings.txt, and it's got 3 Bigfoot sightings, 1 for each line. And if I run my .NET app, .NET run my pipe in or redirect in sightings.txt, it will take those 3 sightings and spit out results. And so this one does something a little different here, right? We've got these 3 numbers here, and then we've got a class right here, and then we got echoed back the sighting that we sent in. And so what this is telling us here is that these should add up to 100% or to 1. And so this is saying it's roughly 60% certain it's Class A, roughly 39% certain it's Class B, and less than 0.5% certain that it's a Class C. And you'll see the Class C is usually about 0.5%. And that's because I don't have enough Class C Bigfoot sightings to really do meaningful machine learning against. I probably should have removed the Class C sightings from it, and that probably would have opened up additional algorithms for DataRobot to use, because I could use some of the binary classifying algorithms, because we just have a Class A versus Class B. But in here, in the case of the Class Bs, you can see it's 10 and 26%, and then it's in the 80s and 70s here. So this is giving you an idea of how sure it is, right? It's more sure that this second Class B sighting is Class B than it is that the first Class A sighting is Class A. And I'd be willing to bet, I mean, I haven't tried it, that this particular one that we did here would be narrow. Actually, let's find out. So I'm going to hit the REST API directly using Postman. Everyone familiar with Postman? It's like curl, but you can use it. I mean, curl's super powerful, but you try to use it, and you're like, okay, what flags do I need? Oh, I know, I'll just do curl -- help. Scroll, scroll, scroll. Okay, I'll do curl -- help pipe grep, and then I can't find the thing I actually want, and I'll just use Postman. So in this case, I got a Classinate URL here. My header is saying the content type's JSON. Let's put that text in here. That worked really well. Hit send. And did it work? Okay, yeah, it got back. Actually, it's very sure that it's Class A. So it's probably picking up on some keywords or something. It's interesting that Bigfoot was carrying a staff. I don't remember Dad having a staff. But anyhow, so I've hit the site itself. There's also a little get thing here where it just returns the name of the app, the attribution, and the version. That's the app I built that uses this ridiculous data to do ridiculous things. Which code base would you guys be interested in seeing? Oh, we got these pieces here. So we've got iOS and Swift, which this is the .NET group, so I figure that's probably a no. We've got the Vanilla.js application, and this guy here is written in C#, which since this is the .NET group, this is probably one I should do.
So let's start with the C#.
And then we can take a look at the Python code here as well. Just, you know, if you're doing machine learning, Python always comes up. Although the way this is built, it wouldn't have to be Python. It's just what I chose to do it in. So that I could give this talk at Python user groups. So let's take a look at the C# code here. That is the JavaScript code. Here we go. So I haven't looked at this code in about a week, and so it may have all fallen out of my head, but we're going to go through it anyhow. So when you start out, we've got this program class that I wrote, and it just has a main function. And all it does is parse your arguments and then delegate things to what I'm calling a controller. I used a sort of a loose idea of a model view controller in building this command line tool. And people usually don't talk about MVC with command line tools, but there is a model. That's the thing that does the classification. There is a view. That'd be things that are read from and written to the command line. And there is a controller, which is the thing that's coordinating the activities between the view and the model. So we've got the same three concerns. It's just command line instead. It's just text instead of GUI, but it still works. So I look at the, I instantiate a controller here. I say, hey, are there args? No. Is the input redirected? In other words, am I piping stuff in? Yes. The controller is going to classify, going to classinate. Was input redirected? No. Well, then the clear thing to do here is to display the help screen, or the help information. If there is arguments, and the first one is -v or -- version, then display the version. Otherwise, they did something wrong, show help. Or maybe they did help, but it still ends up there anyhow. So this is just sort of parsing your command line arguments and delegating to a controller. Actually, if you look at the command line tool, if I do -- version, it sits out and spits out the name and the version number and AI by DataRobot.
Did you have a version 1?
I did actually, and it's evolved a bit over time. So I'll probably be building a version 3 here pretty soon, because I'm gonna have some new tools to do this with. So that's the main program. Let's take a look at the controller. So the controller's got basically 3 things it responds to, 3 events it reacts to. They ask for help, in which case it tells the view to display help. They ask for the version, in which case it uses the model to get the version information, and then it displays that version information, passing it in. Or they are classinating, in which case we tell the view, display the titles, the class A, class B, the header row, and then loop through all the sightings that we read from the view, and classinate each one in turn, and then display that result. So have the model classinate it, have the view display it. So the controller's not doing a ton here, but it's a good separation of concerns here. Let's take a look at the view. Here is, we'll start from the bottom here. Display classination just takes a single classination and sighting DTO and displays its contents in a CSV format. So it takes the values for class A, B, and C, those numbers that we saw. Which one was selected, and gets spit out there. And then this is my super sophisticated way of making it CSV. In case there's any quotes in the data, it escapes them properly. So I do not vouch for this being good for production environments. And then it puts a carriage return at the end. So this is just displaying a single classination. This is displaying our titles. You can see it's just displaying, I mean, it's just console.writeLine. Our version is taking that data. It's all console.writelines, right? Here's our display help. And then this is kind of interesting. So this is reading the redirected input. And so I just create a list of sightings. And then I read a line from the console until I don't have any more lines. And every time I read a line, I add it as a sighting object. And then I read the next line and just loop until they're all gone. When I'm done, I convert the whole thing to an array and return it. And so this is what the view does. The model is then got an adapter. And the adapter is the thing that knows how to talk to the REST server. And the model is just providing the asynchronicity of talking with that. So we got the async await stuff happening here. And so if you call info, then it calls fetch info on the adapter and then converts it from JSON into DTOs. So it's deserializing it. And the same thing here, if you're doing a classification, we pass in a sighting. And we take that sighting, turn it into JSON, pass it into the adapter as JSON, get JSON back as a response, and then convert it back to the object. So this model is primarily doing JSON serialization and deserialization. And then the adapter is just doing basic HTTP I/O. So there's not really a lot happening in here. This is not like super advanced .NET code here. I'm just using systemnet HTTP, and I've got my base URL and my default headers set up here. When you call fetch info, it just does a get because that's an HTTP get. And then we do the classonate. We call it /classonate with a post, and we pull that data out. So we're just doing some basic HTTP manipulation or calls from .NET here. And that's the sum total of the .NET code. So it's not actually terribly sophisticated. Most of the smarts is happening in the REST service. But even the REST service itself isn't super sophisticated because really the machine learning is happening back on DataRobot. So, so that's the .NET code. What else would you guys like to see? Your stunned silence is very reassuring.
Are you versioning your API?
Of course not. Backwards compatibility is for schmucks. Or for what was it? I can't remember. There's something I used to say at this one client all the time. It wasn't schmucks. It was something else. But anyhow, it's for suckers maybe. Well, let's take a look at the Python code so you can see what's behind that REST service. Because you can imagine that the JavaScript code that we wrote and the Swift code we wrote are doing very similar things to this, just with UIs. So here's the Python code. And so what this service is really doing here, we've got app.py, and here we're bringing in Flask, we're bringing in Flask cores, so we can do cross-site scripting. I've created a class called a Bigfoot Classinator model that allows us to encapsulate the DataRobot model so that it can take those JSON objects and turn them into easier things to work with. And I bring in Flask here. So if you call info, I just return a hard-coded basic JSON object. This JSONify in Python takes this Python hash or dictionary and turns it into the expected JSON structure you'd have if you handed a dictionary. If you wanted to take a dictionary and make it into JSON, it does that. This settings object is just a little Python class I wrote. It's got some constants in it. These are hard-coded. And then like the API token, the username, the DataRobot key are all environment variables because I don't want to share my DataRobot key with everyone on GitHub because then everyone would get free machine learning on my API. And I would probably make someone at DataRobot mad. So Yeah, that's right. It'd be great, no problem. I can actually invalidate my key and generate a new one if I do that by mistake. But and then this is the URL to hit our deployed model here, and then this environment variable is the deployment ID. So it's just being used inside of this URL. So these are settings that we use in, here, and I'm taking app name and version and the attribution and returning them, and then I print them out just so I can see them in a console log, because print is how you do console logging, right? That's how you do logging in your applications, right? Here is app.route classnate. So it's a post. It also supports cross-origin. And this one's a little more interesting because it gets the JSON string and then gets the sighting object out of it. You might remember when I hit this thing from Postman. We have just a JSON object with sighting, right? That's what this is doing right here. We're pulling just the body of the request out. And then we instantiate our Bigfoot model, our Bigfoot classinator model. And then we call the classnate method on that, passing in that string. So model.classinate, and then the text that we want to classify. And that's going to return a classination object, which we're then going to turn into JSON. The classination object here, if you look, it's got, you can parse it from JSON or convert it to a dictionary. And the toDict tells us the values for class A, B, and C, and then which one was selected. And you might remember seeing those in the .NET tool. And then it returns it. And so let's take a look at the model, the classinator.py. And so for the classinator, what we do is we take the sightings, the sighting you passed in, and we need to create a pandas data frame. And I'm only doing one because that's the API I want, but DataRobot actually supports many, so you could send in like, dozens or hundreds or thousands even if you wanted. And you'd have an array of these objects, of these dictionaries, and you'd build a data frame from that. And then we convert that data frame to JSON, orienting it for the records. And then we can use this little DataRobot adapter that I wrote, which is just sort of a wrapper around the URL for DataRobot, and call the predict method on that with that JSON. And then that's going to return a prediction, which is itself JSON. And then we parse that JSON into one of these Bigfoot classination objects and return that. The DataRobot adapter itself is got all the stuff for talking. There's several things you got to set up for that. You got the URL that you want to hit. You need some auth tokens here with the username and the API token in this tuple here. And then you got to specify these headers, and the DataRobot key's got to be in the header. So you've got a username, an API token, and a DataRobot key that all have to be passed up to there. And then you just do using requests, which is a library that ships with Python. Pretty sure it ships with Python. I don't think is it in my requirements.txt? Nope. Yeah, it's part of Python then. No, it is something I brought in. Never mind. So it's a library I installed with pip. Anyhow, we import that, and request.post. Here's your URL. Here's your auth headers. Here's your headers. Here's the data that's part of the post, the body. It's going to return a response, and then we'll convert that to JSON because it's just binary. It's not anything. It hasn't been parsed into anything, and we'll return that. So, but this sort of wraps up that idea of calling DataRobot and makes use of those settings and stuff to allow that RESTful service to work. So yeah, let's see how we're doing on time here. I think I'm almost out of time. So
Go as long as you would like.
well, it's more as long as they would like. So I don't want to be too tedious here. Is there anything else anyone wants to see out of the tools that we use to build this? or that I used to build this, I guess. You guys didn't do anything. You just sat here and watched. Did I say watched? I meant played on your phones. Come on. Oh yeah, you can do this in anything. I honestly, what I did was I built 4 pieces in 4 different languages so that I could give this talk at a .NET group, and I can give this talk at a Python group, and a JavaScript group, and an iOS group. So, yeah, you could build this in anything though. This, the only thing that's kind of Python-y in here is in the Classinator. I'm doing this pandas data frame thing here. But even then, what the JSON it puts out is not complicated. And so you could just create that JSON. I've done it from Postman without using pandas, right? You don't have to. It's just sort of a shortcut. It's a very data scientist solution to the problem. As a developer, I probably never would have thought to use that. But one of the data scientists on our team said, hey, you should use this. And I'm like, oh yeah, that is a convenient shortcut. So I used it and it worked. So, but yeah, you're right. This could be this backend could all be written in .NET Core. Quite honestly, all this DataRobot stuff probably could be embedded in the application, except you'd have your keys in there. And since it's a deployed command line tool, you'd want those keys in there. The other advantage of doing it with Python is I was able to deploy it to Heroku, and then, and that's free. So I didn't have to spin up like an Amazon instance or anything. So
how easy was it to train your model in using DataRobot?
I can show you that if you'd like. Let me let's see. There's the demo. Yeah, we can do that. So I've got DataRobot up here in case someone asked that question. So this data here is auto mile per gallon, but I can bring up the Bigfoot Classinator. So I uploaded a CSV file to DataRobot that had 2 columns, the text and the class. I actually ended up with 3,640 records that were usable. I went through, and of those 4,586, roughly 800 of them were missing either a class or the observed column, and so they weren't useful. So I took those out, and so I uploaded them, and then once I uploaded them, there's this autopilot button that shows up at the top. And I could rerun the autopilot right here if I wanted to. I'm not going to do that right now. And it went through and built me 34 models. And scored them and everything and picked recommended models for me. So the average blender here is the most accurate, but the stochastic gradient descent classifier was actually a lot faster and just a tiny bit less accurate. And so, but it built all these models for me. So I can like expand these models out and look at them and say, what's this one look like here? You see the data comes in, it does some pre-processing, runs it through 3 different stochastic gradient descent classifiers, averages the result of all 3 of those classifiers, and then uses that to make a prediction. So that's what our blenders do. We take multiple models and average the results. You can look at your model and understand it. You can see like the impact of the features when you're looking at these models. I only have 1 feature, so its impact is huge. Right. But if we go to like this other thing here, I've got the auto mile per gallon. I built several models with this, and if we look at the data, we're trying to predict the miles per gallon of a car. We got a data set of classic 70s and 60s cars that get shitty gas mileage. And then we got like the horsepower and the weight and displacement and how many cylinders it has and all these things that would impact miles per gallon. And I hit that autopilot button, and it built me 39 models. And here I got a support vector regressor. and it's showing again that sort of how it builds that. But if I go to understand and go to feature impact, you can see it shows the impact of the different features. And so weight is the biggest impact on your miles per gallon, which makes sense. Your model year is actually the second biggest one, which I treated that as a category, even though it was a number, because it's really categorical data. It's not something we're going to do math on, right? And then it actually detected displacement of the engine as redundant with weight. And so as the weight increased of the weight of the car increased, the displacement of the engine increased, because you put bigger engines in bigger cars, right? And so it's sort of detecting the redundancy of that, because that's how they were engineered. And so it's doing all that kind of stuff. But to actually build the models, well, let's kick off a session here. Let's create a new project. Let's upload a local file here, and I've got a data set of Puxatawny fill predictions, and the weather for February and March that's predicted, and whether he saw a shadow or not. And so right now it's uploading the data. Let me get a few more workers here. They only let me have 4, but it makes things go faster. And so there we go. Reading raw data. Come on. And so, I mean, these can take a while sometimes. This one goes pretty quick because there's not a lot of data. And so here we go. It says, what would you like to predict? And I can view my raw data. I've got my prediction and the weather. For the average temperature for those 2 months. And it gives you some information about that. And I can go in here and I want to predict the prediction. And it shows me stuff about that. I hit start, and it just starts building models. And then I sit back and go, data science is hard. I just squished the microphone. I'm sorry, internet. So that's how it works. And so that's what I did for the Bigfoot sighting. I didn't use the Bigfoot as an example because it's NLP, and so it takes about 20 minutes to run through all the models. But you see here, we've already got 4 models found. Validation is in progress on some of those. So, and we could sit here and watch this, but that's not going to be very interesting. So, but then it'll rank them, and it'll say, we recommend you use this model because it was the most accurate, or whatever. So, sort of a long-winded answer to the question, but I use this to build a Bigfoot classifier. So, which is kind of fun. Unfortunately, you guys can't play with this product because it's not free, but I have an account because I'm an employee. But you should pay attention when I post on Twitter, because there could be news. So, and that's all I'm going to say on the internet.
Community edition.
Well, it is worth asking the question, if we don't have a developer-friendly product, why do we have a developer evangelist?
Polishing up your resume, huh?
Yeah. Or there's a reason. So, but that's pretty much all I've got. There's the Beyond the Model GitHub URL that has my slides and stuff like that. And if you want to play with the Bigfoot Classinator, I created an organization actually for it because I had so many projects. I just wanted to group them. So you can go out to github.com/Bigfoot-Classinator and play with the code that I wrote. And we sort of had questions already, but are there any other questions? Okay. That's a picture of me and my contact information. This is the data. This is a link to the BFRO in case you want to go out and check out their stuff. It is quite entertaining. And then here's Tim Renner's data.world account where he posted the Bigfoot sighting data. And that's the DataRobot logo. And that's all I got. So, thanks.